My name's Zach, and the book I chose to do was How Not to Be Wrong, Power of Mathematical Thinking by Jordan Edenbrough. He's actually a pretty pop culture mathematician, as I found out. And the book really focuses on the problems with linear thinking, and linear thinking being like applying current patterns to a future that you might not know about. And they talk about one reporter who's quoted saying that the United States is moving to become more like Sweden, yet Sweden is trying to become more like the United States. So how does it make sense that the government is trying to do this? Well, they acknowledge that, and so essentially, the idea or the thinking that the reporter is using in that context, is he's using a linear thinking, which is a model kind of shown here, where prosperity is on the y-axis, and what was deemed in the book as Swedishness is on the x-axis. And basically, your best case scenario is where you're the least amount Swedish and you have high prosperity, which they deemed libertopia kind of as a joke. And then you have USA, which is here, not very Swedish. You have Sweden over here, and then you have the black pit of socialism, which is on the far right, which is way, way past Sweden. And so the argument they're making is, why would the USA move this way to become more Swedish when Sweden is moving this way to get more prosperity? Well, the idea there is that they're making a correlation that can't be assumed to be true. They're assuming that this relationship is linear, when in actuality it is likely more nonlinear, as reflected here, where the USA is approaching prosperity and Sweden is also approaching prosperity with a maximum point right here in the middle. And this is a relationship that is kind of complicated to arrive at your own conclusion, but an economist with the last name Laffer invented this, which is the Laffer curve. And it's an oversimplification of a trend, which has the middle being just a parabola. It's likely not like that. It's likely curvier, but this is a simplification. And basically, what it's kind of pointing towards is that 0 and 100 produce the same undesirable result. And so having either end of the spectrum is unfavorable, so there exists some point in the middle, however curvy this line may be, where it is in fact maximized. And so neither a perfectly US or neither perfectly Swedish country would be maximal. They'd both be at 0 over here. And some point in the middle in between them is actually where you want to be. For this segment, I thought it'd be helpful and more interesting if I could provide my own example of a similar idea. And I came up with the relationship between time spent studying and your grades. And so essentially, this idea that if I study more, maybe my grades will always be better, and that's kind of like a linear thought. So if you actually spent none of your time studying, you wouldn't get very good grades, pretty obvious. If you spent every single moment studying, would you then receive the best grades possible? I would argue that that is not the case, that in fact we're looking at a parabolic or a more Laffer type curve, because if you spend no time studying, you get bad grades. That's right here, right on the 0. But then if you also spend all of your time studying, 100% of your time is spent studying, you don't sleep, you don't eat, you don't do anything, I would argue that, I guess more morbidly, you would eventually die, and in that case your grades would drop down to 0 also, because you wouldn't be functioning at an amount that is like considered to be humanly optional. So the curve itself isn't actually reflecting what is like a linear curve, not more studying is better grades, but in fact it's somewhere in between 0% of time studying and 100% of your time studying. There exists a maximal point. Once again, this is simplified, so the curve is mildly more likely wavy and has ups and downs, peaks and troughs. But this exists as a Laffer or a parabolic curve. So the 100% and the 0% both reflect a 0. Chapter 2 and its main components were very mathy, very math-oriented, but they explain a lot of calculus. But I didn't think that was super important to explain for the class. So I took one section, which I thought was kind of cool. I'm going to go over it really quickly. The idea that 0.9999 repeating to infinity is actually equal to 1.0. And this is a proof they actually show in the part of the book, where if you take 1/3, which is equal to 0.33333, and you multiply both sides of the equal sign, you get times 3 times here, 3 times here. And so you can move the 3 up to the numerator and you get 1. 3 over 3, that's 1. We know that. And then on this side, you get 0.33333 times 3, which you type in a calculator. You can do it if you want. It's 0.99999 repeating. That's assuming the decimal goes on to infinity, just like 0.33333. And here you go. You have the equation of 1 set to 0.9999, which is a proof that that is, in fact, a true statement. All right, and for Chapter 3 and 4, Chapter 3 brings up the point a reporter made that essentially brings up a fallacy with the overuse of a trend line, which is very possible in statistics, and reporters do it very frequently when they don't have an understanding of mathematics. So right here for Chapter 3, you have the idea that the reporter says is that in 2048, every single person in the U.S. will become obese, which is a ridiculous claim, obviously isn't true, but the math backs it up in a way that logic doesn't. And so basically, what the population is on the y-axis, or percent of the population's y-axis, x-axis is the year. So in 1987, you have relatively, probably 50%, or a little bit around there. 2013, the reading is significantly higher, and the readings in between also show a positive correlation. So the reporter draws a trend line, takes the equation of the trend line, and expands it up until the point where the y-axis reaches 100%, and that point right here is found to be at 2048. Seems right, right? Well, it's actually a really blatant oversimplification. The curve more likely reflects an asymptote like that, where it levels off at some point. We don't know the point. But it's more true to say this. They're making a prediction too far into the future with too little data. This happens a lot, and it was important to notice exactly when that happens. And so it's using math to tell a story that isn't completely true. Chapter 4 then moves into what's called the law of large numbers. It's also known as regression to the mean. This is an example. I just put trials, but coin flips is a good example. So if you flip a quarter like 3 times, let's say here you're at 0, there's 1 flip, 2 flips, 3 flips. So you got your first flip heads, second flip tails, then you got heads again. And then as you move forward in more and more trials, you're getting closer and closer to the mean, which is of course going to be 50-50 split between heads and tails. And that idea of regression towards the mean with more and more data points is commonly used in the world today for giving out grants to bigger schools. So bigger schools with more students taking more standardized tests, they're going to be closer to the mean, whereas if you have a smaller school where you have fewer students and there are fewer data points, those schools stand to both score higher, but they can also score lower because they regress towards the mean fewer when it has fewer data points. And this is seen all the time today in like school funding and grants. This is a huge issue that people are trying to confront, and actually impacted my school when I was in elementary school. All right, the next section was Chapter 5, which I think was the most interesting but also the most complicated. It basically shows that when you're dealing with percentages and net gains or losses, the result can be kind of tricky and very confusing to read, and it's usually a bad idea to do so. And so to kind of show this, we have the income data from 2009 to 2010, and this was the recovery from a recession, so it's a general net income, or the total net income increase, so the whole country is making more money, essentially. And 93% of that increase, which was like, it was like 1.3 million or something like that, was the new income went to the top 1%. And so you can already tell that that means that the new money being made, the vast, vast majority of all that new money is going straight to the 1%ers. And they break this down to a pie chart, which makes it even more interesting to look at. So here and here, these both reflect the top 1%. This guy being the 1% of the 1%, the super, super rich, he's holding 37% of the new money that is made in 2010 compared to 2009. It's going to the super rich, 37%. Then the people that aren't super rich, still 1%ers, they're rich, they're taking 56% right here, And then basic math of a pie chart, you know, the bottom, or I guess the rest of the 7% goes to the U.S., or the rest of the U.S. And you can tell that's an unequal sharing of wealth. And so to break that down even further, all right, so to build upon the previous topic, rather vexing is that if you actually, so you take this graph that we just drew, which is clarified, and you have your 56% here, which is the rich, and your 37% here, which is the super rich. They both make up the 1%, and the total of their total income, or the total new money, the money gained from 2009 to 2010, they make 93% of it, which we clarified earlier. So then you go back into the data, and you say, all right, well, let's look at the top 10%, the lawyers that are non-elite, family doctors, engineers, accountants. They make like about 130 to 160 grand in income. And they're the top 10%, but you exclude the 1%. These guys are getting about 17% of the new money that's coming in between 2009 to 2010. And then if you're taking that 10%, excluding the 1%, you add back in the 1%, which is making 93% from the total. 93% is the total of the rich and the super rich over here. And then the percentage comes out to 110%, which means that they're making more money than 100. So they're making more than the actual money that they received. And logically, you can see why this doesn't make sense, and this proposes a problem in a confusing topic that the numbers don't actually add up to 100. What we can go into in the next part, we'll talk about why it is that, and it's actually because this percentage has negative numbers associated with it, and so there's numbers dragging it down, and we're going to see that the bottom 90% is going to be what's going to actually drag it down. To explain our pie chart that has seemingly more pie than actual plate, as they say in the book, you got 110%, which means that you have 110% out of 100, which means you have more than you actually can have, which is very confusing. But then you break it back down, and you look at the bottom 90%. So you take your 10% out, and you look at just 90 down. And you look at it, and you see that the net income actually drops from 2009 to 2010, which is the key point here. So the bottom 90% makes negative 10% of the new money made between 2009 and 2010. Negative 10% meaning that they don't actually gain money from it, they actually lose money. So they're actually doing worse in 2010 than they did in 2009. So they have 10% of the new money is basically taken away from them. They gain a loss, essentially. It's like a good way to think about it. And so the money is just taken. And so then if you take this 10% from the 90 and you take it, you put it back over here with our original equation we wrote, and you're taking a negative 10% from your 110%, you're moving back and you're back at 100. And that's why you can have more than 100 in the pot, because when you're looking at the top 1% and the 10 excluding the 1%, you're looking at just a portion of it, everyone who did well. But being that the percentage adds up to over 100, that means that, of course, in economics, someone is doing poorly. And more often than not, the book even states that the 90% down is going to feel the blow most likely. And so this is like a very common trend that we see if you look into the economics in the past few years, even more so in the 1900s, where the economic rebound and economic increase is seen just in the 1%, or the 10%, and even more so in the 1%, even more so still in the 0.001%. They are making all the money, and the people that are feeling the recession and feeling most of the money lost are actually in the 90% and below. One good way that a lot of the stuff that we're talking about here relates to class is in the idea of a pathos argument, as depicted right here. It's a pathos-driven debate in statistics or any math that you're trying to use to persuade somebody. It's a fallacy in which someone finds a data point or a data pattern in which they want to be true. They have math or simple mathematics to prove that it might be true, and so therefore they accept it as truth, which is seen with the abuse of linearity. Talked about it in chapter 3, or the Laffer curve in chapter 1. They all reflect people using math to prove a point that might not actually be true, but they're blinded by their own desire and own emotion and own sort of want to persuade others or even manipulate data. And they're mathematically stable, but in practice, you got to understand what your numbers are saying, because it's not just mathematics and statistics. There's a meaning to all these numbers. They're not just numbers. And so when people bring in pathos to arguments like this, and they have the explicit desire to persuade or pervert data, you're going to see stuff like this. And it's important that I think people read this book, and I think that it should be a book that a lot of people read. And you realize in the real world, like even I talked about how the regression to the mean, right behind me, right here, that's an issue that actually worked its way into my elementary school system. When we had a standardized test we'd have to take every year, and the larger schools would never get grants because they'd have larger sample sizes. They'd regress towards the mean more versus smaller schools where they have fewer individual samples, and so they'd have a larger ability to get these more extreme points here versus a larger school that's further down here with more trials. They're going to be more regress to the mean, but then your small schools are going to score both your lowest and also your highest in that regard, and they'd always get the grant or they'd always get cut funding, but it would be unfair for large schools. And that's the kind of like statistics and math driven stuff you read about in this book that I think is very interesting and important for people to understand. So I think most people should be able to read. So I'm cutting myself off, but I wanted to add one more thing before I was done, was that the part on percentages right here that we just talked about over here is also very important. It's very commonly used in politics to kind of manipulate and pervert statistics and percentages to make certain things, values come out to like 90%. Like there was something the book noted where when Obama was first in office, Mitt Romney cited a source that was factually correct that 97% of jobs lost while he was in office was female jobs, which is factually true if you go through the details. And it even cites it in the book of why it's true, but it's told in a way where that figure doesn't really make a whole lot of sense to report, because there's net losses and net gains and their percentages, and so it can really confuse the way that the numbers are written. And if you don't understand why it's confusing, and you don't understand how that number might not mean what you think it means, it could be very persuasive. It's a 97% is almost 100. That's pretty huge. And so it's important to understand and read this book just so you get a grasp of things that might trick you. Like when people are trying to persuade your opinion, they're going to do what they can. They're going to use their pathos, and I think pathos ends up being stronger arguments in the end. So when you say that women felt 97% of job loss, that generates quite a bit of emotion, and it really does kind of change your opinion versus just the logos. Even though it is true, it's meant to generate an opinion. It's not inherently true. And so I think because of that, it's very important that people would read this book and form their own opinions and read the data themselves and understand for themselves rather than taking numbers that someone else presents with them, because they are probably saying numbers that makes them look better. They're not trying to give you good information. And so, yeah, it's an important book to read. I would highly recommend it to anybody, and thank you for watching.